Okay, now we'll talk about section 10.3, which is the connection between the linear and rotational quantities. As we see in the previous section, there is a connection between V and omega, A and alpha, theta and x. Now we will see that. Look, if we need to make a full rotation around a circle with radius r, then the total circumference will be 2 by r. If there is a body moving and this body has a velocity v, then its velocity is equal to the distance, total distance, divided over the time. The time is t capital, which is the period. The distance is the circumference, which is 2 by r. This is all of it, 2 by r, divided over the full time, which is the period. This is the velocity or the speed. The velocity is a vector, but we have here a tangential speed. The tangential speed is equal to 2 by r over t. But if we take r out of this term, it will be r multiplied by 2 pi over t. 2 pi is the total angle, which is 360. This is one rotation during total time t. We call this is omega, the angular velocity. The angular velocity is the total revolution over one period of time, which is t capital. So the velocity or the speed will be named vt. Tangential speed is equal to the radius multiplied by the angular velocity. Okay, the tangential speed is equal to the radius multiplied by the angular velocity. Also, if we talk about the acceleration, if you remember, we study the centripetal acceleration AC, and we find that AC is equal to v square over r. V square, which is the tangential speed squared over r. But now we find that V tangential is equal to r omega. So we put it r omega squared over r. This will be equal to the centripetal acceleration is equal to r squared omega squared over r. We can cancel this r with one of these r's. We have two r's here. Then that centripetal acceleration will be equal to r multiplied by omega squared. Omega, it is the same omega, what we know it. Okay, so now we find the centripetal acceleration in terms of r and omega. We have a connection between the tangential speed, which is a linear speed, with the angular speed. Just the connection term is r between them. Also, the connection between the acceleration and omega squared is also r. Also, what if we have alpha? Alpha means change in omega with respect to time. What if omega is not constant? What if we have acceleration or angular acceleration, alpha? Okay, then if we have change in the angular velocity, then the tangential velocity speed at the circle edge will be also accelerated. If we have acceleration, angular acceleration alpha, then we have tangential acceleration. Okay, so V tangential will be changed with respect to time. V tangential is equal to r multiplied by omega. any change in V tangential is equal to R multiplied by the change in omega. With respect to time, both sides, delta omega over delta t is alpha. It is alpha, which is the angular acceleration. So the tangential acceleration is equal to R multiplied by the angular acceleration. Now the tangential acceleration is connected to the angular acceleration by R also. Okay? Look now at this circle. If we have a moving body on its edge moving in this way, this is V tangential, and this body also have acceleration tangentially. Okay? By the way, because of this body changing its direction, then it has a centripetal acceleration AC. We find that A tangential is connected to the angular acceleration in this formula, and the centripetal acceleration is equal to R omega squared. We find that this is AC and this is AT. Okay, we have two accelerations now. This acceleration is vector. Also, this acceleration is vector, but the direction of AT is tangential to the circle edge, and AC is direct to the center of the circle. We need to find the resultant acceleration for this motion. Okay, fortunately we have the angle between the two accelerations is 90 degrees. Then we can apply Pythagorean theorem. If we take this is equal to AT, then as the right triangle, A total, we can name it A total, is equal to root of AT squared plus AC squared. And we can put the values of each one from the formulas. And we need also to find the phi, the direction of this acceleration, total acceleration, which is phi from the tangential direction for this circle. Phi is equal to tan inverse AT, which is this side, over AC over AT. This is phi, this is AC, this is AT. So phi is equal to tan inverse AC over AT. Okay, now we will solve an example. If we have a car going around circle, the radius of this circle 25 meters, the speed of the car around this circle is 20 kilometers per hour, and this car also has a tangential acceleration which is 2 meters per squared second. Okay, is that clear now? We need to compute the angular velocity and the angular acceleration and the centripetal acceleration. We need to find A total. We need to find the phi, which is the direction of A total. This is A total between AC and AT. Okay, now first we know that the tangential speed is equal to R multiplied by omega. We need to find omega. We know for R, we know Vt. Omega is equal to Vt over R. Vt It is in kilometers per hour. Be careful for that. We need to convert it. 20 kilometers per hour, we need to multiply it by 1, which is 1,000 meter over 1 kilometer. This is 1. This is the conversion coefficient between 1 meter, between meters and kilometers. Also, we need to convert the hours to seconds. So we need the convergent coefficient, which is 1 hour is equal to 3,600 seconds. In this case, we cancel kilometers with kilometers, hours with hours. So we have 20 multiplied by 1,000 divided by 3,600, which is equal to 5.6 meters per second. Now 20 kilometers per hour is equal to 5.6 meters per second. Okay, omega is equal to V over R. V is 5.6. The radius is 25 meters. Then the angular velocity is 0.22 radians per second. Now we find omega. We need to find alpha. Okay, we know that from the formulas that the tangential acceleration is equal to r multiplied by the angular acceleration. Then the acceleration in angular direction is equal to at over r. At is given 2. R is given. Then the angular acceleration is 0.08 radian per squared second. We find the angular acceleration. We need to find AC, the centripetal acceleration. It is easy. We have two formulas now. We have the old formula, which is AC is equal to V squared over R. We have the new formula, which is R omega squared. Okay, let us now find it by the first one. V squared, it is 5.6 squared over 25, which is R, which is equal to 1.2 meters per square second. Now, the new formula, R omega squared, R is 25, omega squared 0.22 squared, it will be the same magnitude. The acceleration is the same using the both formulas. Okay, now we need to find the total acceleration. As we tell you before, it is A tangential square plus A centripetal square. AT 2, AC 1.2, AC 1.2, AT is 2. It's given. Then the total magnitude of this acceleration is 2.3. We need to find phi. Phi is AC, as we said, over AT. AC is 1.2 over 2, which is equal 1.2 over 2, which is equal to 30.96 degrees. It's okay. We find it in degrees. We don't need to find it in radians. We can convert it to radians, but just we need to know the direction of the total acceleration. This is a live example. You can use it. Try it alone. Solve it again and try to solve another questions from the book. This is all for this lecture. Thank you.